Illicit promotion has existed in the web realm for decades. Various techniques assist cybercriminals in illicit promotion, especially with recent advancements in artificial intelligence. Now, let's look at how these cybercriminals promote their illicit online businesses. In the context of real-world illicit promotion, cybercriminals have two main goals. The first is to advertise illegal businesses on compromised pages. The second is to boost the rank of these compromised pages in search results to increase their visibility. To achieve these goals, cybercriminals resort to various techniques. For example, cybercriminals use black hat SEO techniques to manipulate search engine rankings by modifying compromised pages. Keyword stuffing is a typical technique, where keywords are repeated on the compromised page to increase its relevance to the targeted query and improve its rank. Other black hat SEO techniques include link farm spam, cloaking, redirection, and so on. While developing state-of-the-art techniques for promotion, cybercriminals also seek suitable platforms to promote their content. Researchers have found malicious vandalism on Wikipedia, such as for-profit link spam, and edit wars involving extreme political labels. Facing prolonged and worsening vandalism on Wiki systems, Wikimedia and third-party volunteers have developed and deployed multiple vandalism detection tools. For example, Wikimedia has deployed ORES on Wikipedia and Wikidata, while ClueBot NG and AVBot from third-party volunteers have also been deployed on Wikipedia. With various state-of-the-art attack techniques for illicit promotion, can cybercriminals attack Wiki systems and use them as a platform for illicit promotion? And can Wiki systems always defend against vandalism with these detection tools? To answer these questions, we investigate whether Wiki systems are still susceptible to illicit promotion in real-world scenarios. Unlike illicit promotion on Wiki, traditional black hat SEO and recent ranking manipulation research focus solely on boosting article rankings. Successfully attacking the real-world Wiki system and its search engine is much more challenging. Cybercriminals must overcome multiple obstacles and meet numerous attack objectives to execute a successful attack. For example, cybercriminals would face state-of-the-art vandalism detection tools and user content moderation mechanisms. More specifically, for real-world Wiki illicit promotion, cybercriminals need to achieve the following objectives simultaneously. The first objective is that the promotional content can be inserted in the target article, along with Wiki-style context. The second is that the ranks of the revised articles are significantly improved among query results. The third is that the revisions cannot be detected by Wiki vandalism detection, even when the detector is black-boxed to the adversary. The final one is that the content of the revisions does not arouse any suspicion from Wiki users, but still captures their attention by maintaining the semantic consistency and topic relevancy of the revised articles. In our attack, cybercriminals are assumed to have the right to edit target articles in the Wiki system, similar to public Wiki systems. Cybercriminals can acquire the ranking score of each search result returned from the Wiki search engine through a public API and the vandalism detection result of each edit from the edit feedback provided by Wiki systems or an ORES API without any restrictions. We assume that cybercriminals do not have whitebox access to the Wiki search engine and the vandalism detection tool. Additionally, our focus is on text-level illicit promotion. Injecting malicious links, such as Wiki link spam, is out of the scope of this work. In our study, we investigate how to generate text revisions that meet the above objectives and evaluate the effectiveness and efficiency of our proposed approach. We also study defense approaches to combat such illicit promotion on Wiki. In the second section, we will introduce our approach for illicit promotion on Wiki. Before the attack, cybercriminals are aware of the content they need to promote, such as illicit online pharmacies. They also receive a specific query as their target, which should lead to the promotion content appearing at the top of search results. The pipeline of our proposed approach includes 5 steps. First, we fetch the target Wiki article. Next, we generate candidate promotion paragraphs. Then, we retrieve a suitable promotion paragraph from the candidates. After that, we identify an insertion position within the target Wiki article. Finally, we insert the suitable promotion paragraph into the target article. This approach is named Multitask Adversarial Wiki Search Engine Optimization, or MAWSEO. To promote an online pharmacy that illegally sells fentanyl, the first step aims for targeting Wiki articles fetched from the search results of the query fentanyl, such as designer drug and fentanyl crisis in San Francisco. The second step, generating candidate promotion paragraphs, is the key step in the data preparation for stealthily polluting Wiki articles, ensuring the polluted article can evade vandalism detection and not trigger users' alarms. Thus, the generated candidate promotion paragraph should meet 3 requirements. It should contain promotional content, ensure grammatical correctness and language smoothness, and be written in Wiki style. We collect all paragraphs related to promotional content from the open access Wiki text database, such as Wikidump, and use them as raw paragraphs. To promote an illicit online pharmacy, we design and train an incentive injection model that strategically adds promotional content into raw paragraphs. The model takes the promotional content, target query, and raw paragraphs as inputs and returns the candidate promotion paragraphs. To ensure language smoothness and grammatical correctness, the incentive injection model is designed to add promotional content to a raw paragraph by replacing existing words or inserting after the existing words. The incentive injection model first runs a binary attention-based named entity recognition model to identify terms in the raw paragraph that are semantically and grammatically related to the promotional content as suitable for revision. The suitable terms are then labeled with either a replacement entity or an insertion entity, while the rest are categorized as unsuitable. For example, the term sold is labeled as an insertion entity with a probability of 0.7. Finally, from all the raw paragraph terms suitable for revision, we randomly select a term to add promotional content by either inserting after or replacing the term based on its revision entity category. In our example, ABC Pharmacy is inserted after sold based on its insertion entity labeled by the model. After generating a set of candidate promotion paragraphs, we retrieve the most suitable one for adversarial revisions in a Wiki article. There are 2 main challenges in retrieval. The first challenge is to simultaneously satisfy several attack objectives: rank boosting, detection evasion, semantic consistency, and topic relevancy. These objectives are crucial for successful adversarial revisions. The second challenge is to disorder search ranking and evade vandalism detection in the black box setting, as cybercriminals are unaware of the model structures of the Wiki search engine and vandalism detection tools. To find the suitable promotion paragraph, we propose a multitask adversarial passage retrieval model. The input of this model consists of the target query, the target Wiki article, and candidate promotion paragraphs. The model consists of 2 parts, the passage retrieval network and the discriminator set. The passage retrieval network is responsible for retrieving the most suitable promotion paragraph from the candidates based on the query and the Wiki article. To guide the retrieval process in satisfying multiple attack objectives, we adopt a generative adversarial network design. Using this design, we train the passage retrieval network in conjunction with multiple discriminators, each associated with a corresponding attack objective. Additionally, to overcome the black box setting of the Wiki search engine and vandalism detection tool, we train a local substitute ranker and a local substitute vandalism detector using knowledge diffusion. In this process, we query the APIs of the Wiki search engine and ORES, and use the query results as the training sets for our local models. After obtaining the suitable promotion paragraph in step 3, the next step is to find the appropriate insertion position within the target Wiki article. This position is where the paragraph will be inserted. For example, we need to find the insertion position for a retrieved paragraph in the Wiki article titled Designer Drug. To ensure the inserted paragraph is semantically smooth with the neighboring paragraphs of the target article, we calculate the mean cosine similarity between the retrieved paragraph and each pair of neighboring paragraphs in the article. Using this method, we find the retrieved paragraph is much more similar to paragraph 3 and paragraph 4 in semantics. Thus, the retrieved paragraph will be inserted between paragraph 3 and paragraph 4. Finally, after the insertion, we complete our adversarial revision. In this section, we will introduce our implementation and discuss MAWSEO's performance in the Wiki system. When setting up our experimental environment, the first challenge was selecting an appropriate Wiki system. Since Wikipedia and Wikidata are public systems, conducting our experiment on them would raise real-world ethical concerns and pose potential dangers. Thus, we cannot use public Wiki systems as our experiment environment. However, we found that many Wiki systems and knowledge systems like Wikipedia and Wikidata are powered by the open-source software MediaWiki. In this study, we implemented a local victim wiki system based on MediaWiki for our attack experiments. We also installed the extensions Auras and Cirrus Search to strengthen the vandalism detection and search engine of the local wiki system, respectively, as many wiki systems do. Our local wiki system consists of 123,000 articles and their respective edit histories on Wikipedia. We implemented MAWSEO and evaluated it on this local wiki system against illicit online pharmacy promotion, the most prevalent illicit promotion cybercrime. In our experiment, we attempted to promote 125 illicit online pharmacies on the wiki system. We randomly assigned one target business to pollute the search results of several specific queries. We collected 659 query terms based on the most popular terms in Wikipedia associated with drug names. In the evaluation, we divided the search results into two sets, Top 20 Search Results Set and All Search Results Set. In this way, we obtained 31,000 query article pairs for the All Search Results Set and 12,000 query article pairs for the Top 20 Search Results Set. To train the multitask adversarial passage retrieval model, we randomly selected 527 query terms and their associated 25,000 query article pairs from the All Search Results Set for training and the rest for testing. The raw paragraphs used in our study were sourced from Wikidump, a collection of over 21 million wiki articles. We selected 53,000 paragraphs related to medical subjects as raw paragraphs. To evaluate MAWSEO's performance across different attack objectives, we measure the performance of each objective using corresponding metrics, including rank-boosting success rate, evasion success rate, topic relevancy rate, and semantic consistency rate. Additionally, to understand how many revisions satisfy all the attack objectives, we define the promotion success rate as the percentage of adversarial revision samples that successfully meet all attack objectives out of all the revisions. We also assess the time cost of the attack. In our evaluation, we compared MAWSEO with 3 language generation-based adversarial ranking attacks, including Hotflip, Collision, and PAT. Additionally, to disorder wiki search, we conducted an ablation study by replacing MAWSEO's rank-boosting method with popular or state-of-the-art alternative techniques, such as keyword stuffing, and the synonym substitution-based adversarial ranking attack named Prada. Compared with baseline approaches, MAWSEO outperforms in almost all metrics, especially the promotion success rate, which summarizes the final attack performance on the wiki system. We also detail MAWSEO's performance on subtasks. In terms of ranking manipulation, MAWSEO has a greater impact on lower-ranking articles, resulting in a higher success rate and larger manipulation margin. In evasion against vandalism detection, MAWSEO-generated revisions are highly evasive against various real-world vandalism detectors. To understand whether the content of revisions can still capture wiki users' attention without arousing suspicion, we conducted a user study to evaluate the revisions of MAWSEO. The articles in each questionnaire were from 30 articles revised by MAWSEO, 30 benign articles, and 45 articles revised by baseline adversarial ranking attacks. The user study was conducted through Amazon Mechanical Turk, gathering 104 valid responses. Based on our survey results, we found that articles modified by MAWSEO have high trustworthiness, similar to benign articles. Thus, our malicious articles have the potential ability to bypass Wiki users' awareness of malicious modifications. Additionally, the results indicate that more Wiki users receive promotional content in MAWSEO revisions and accept it as part of the topics conveyed in the Wiki articles revised by MAWSEO. Finally, we identified 30 participants with Wikipedia article review and revision experience and asked them to review our revisions on Wiki articles. The results show that articles revised by MAWSEO have the potential ability to pass the vandalism checks of Wiki reviewers. Faced with the above fact that Wiki systems are still susceptible to the threat of illicit promotion in real-world scenarios, how can we mitigate and defend against such threats? In this section, we will introduce methods for mitigating such threats. Let's turn our attention to the article titled Designer Drug, which has been revised by MAWSEO. Before the revision by MAWSEO, the last sentence of paragraph 3 and the first sentence of the subsequent paragraph maintain coherence in both logic and semantic organization around the insertion position. However, this coherence may be broken up by the inserted paragraph, resulting in reduced coherence between the last sentence of paragraph 3 and the first sentence of the inserted paragraph, compared to the coherence with the first sentence of paragraph 4. Based on this observation, we proposed a coherence detection model to identify revisions by distinguishing the disordered sentence list around two revision joints. For example, the coherence between the last sentence of paragraph 3 and the first sentence of the inserted paragraph is scored as 1 star, while the coherence between the last sentence of paragraph 3 and the first sentence of paragraph 4 is scored as 3 stars. Obviously, the joint between paragraph 3 and paragraph 4 is much more coherent than the joint between paragraph 3 and the inserted paragraph. We designed the coherence detection model by combining a semantic-based discriminative model with a neural entity grid. More specifically, the semantic-based discriminative model recognizes the semantic relationship between two sentences, providing a semantic score. The neural entity grid captures the sentence's logical changes at the word level, outputting an entity score. Finally, our model computes the coherence score based on the combination of the entity and semantic information through a fully connected network. Improving the vandalism detector's robustness is another way to mitigate MAWSEO revisions. To enhance the Wiki vandalism detector's robustness, we used adversarial training, where the defender includes revision examples generated by MAWSEO in the training data. From the test results, we can observe that coherence detection is generally more effective in detecting revisions than adversarial training. Based on the performance of the proposed defense methods, these two approaches can serve as complementary mechanisms to enhance the defense against adversarial revisions in the Wiki system. After discussing MAWSEO and its defense methods, let's further extend our thoughts on its usage and impact. With the emergence of ChatGPT, we have entered the era of large language models. As a potential tool for generating misinformation, could ChatGPT be used as an alternative for real-world illicit promotion on Wiki systems? Based on our experiments, while ChatGPT performs well in crafting fluent text relevant to topics and semantics, it still struggles with specialized tasks like rank boosting and detection evasion compared to MAWSEO. Furthermore, we have tested MAWSEO in illicit online pharmacy promotion. To further understand its effectiveness across different topics, we tested our prototype on illicit online casino promotion. The results show that MAWSEO has similar effectiveness and efficiency in illicit online casino promotion. Our defense methods against casino promotion also mirror their efficacy against pharmacy promotion. This indicates good generalization of MAWSEO and its defense methods across other types of illicit promotions. We also estimate the performance of MAWSEO in attracting network traffic. Based on the past 30-day views shown on Wikipedia, we calculated the average view volumes for articles with different ranks. With this data, we estimated that the adversarial revisions in the test set of all search results would receive 55 million views in the past 30 days, compared to 39 million views before rank boosting. Using the web search conversion rate into online drug sales and the average revenue per action, we can further estimate that the monthly revenue from promotional revisions could reach $110 million by revising more than 5,000 Wiki articles in that test set. In conclusion, we present the first systematic study of multitask adversarial search engine optimization on the Wiki system for illicit promotion. In our work, the proposed MAWSEO can effectively and efficiently generate edits that achieve the attack objectives. To mitigate such threats, we also investigated potential countermeasures.